This new decade is going to be dominated by one invention. No one's life is going to escape its effect, and yet very few people understand what it actually is. So we start our coverage of the technology of the 80s by unveiling the key to comprehending the chip. A switch. Now, what's so magic about a switch? Well, here is a device which takes decisions. Set up like this, it's deciding whether or not to let electricity through to that lamp. Moved to yes, the light comes on. It could just as easily have decided no. And admittedly, that's all it can do. And yet that simple ability makes the switch the very heart of the chip. Because even the most complex decisions break down into a sequence of choices between yes and no. Why, for instance, are you watching Tomorrow's World right now? Well, let's go back to the time when you were at work and had to decide whether or not it was time to finish. Yes, it's time to finish. Shall I eat at home again tonight, or the Savoy? Oh, yes, to eating at home. Delicious. Shall I stay in for the rest of the evening? Yes, I shall stay in, watch television, or, well, what are the alternatives? I shall certainly watch television. Yes to that. BBC on the other side can't stand the bionic mouse, so it's yes to the BBC. Channel 1 or Channel 2, it'll be top of the pops in a minute, so it's a yes for BBC One, and hence Tomorrow's World. Now, that series of yes-no decisions could have been a machine tool, deciding what shape to cut a piece of metal, a washing machine, deciding to stop the rinse and start the spin dry, or a robot, deciding to move from welding the roof to the door frame of a car. Decisions, decisions. The world is full of decisions, and more of them are being taken by switches. Thousands of minute switches, which, thanks to photographic techniques, can be reduced in size and chemically imprinted on slivers of silicon. The decisions a comparatively simple chip can make were the kind you saw in the model truck a little earlier on. Incredible though a system like that seems, a tiny collection of switches is only halfway to a full microprocessor. Although packaged in the same way, the microprocessor not only makes decisions, but it can also store, remember them, until it has enough to let itself arrange a particular course of action. Let me take you now on a conducted tour around a microprocessor. Let's pretend that this chip is at the heart of a futuristic automatic pilot on an airliner. To this central piece of silicon, information is being sent from sensors all over the airliner, telling the system what the aeroplane is doing at the moment. A vast amount of information which the microprocessor has got to handle fast. So first of all, let's consider this bank of equipment down here. This is a program counter. It works like a post office sorting office. An electronic clerk, and in this demonstration I'm the clerk, moves up and down here, picking up the messages as they come in and working out what instructions need to be processed. So, we'll take it very slowly. Message coming in, clerk picks it up. It says, add the incoming message to the one already in the store. Now, I'm not clear what that means, but I know what I've got to do. I take it along the data highway to the electronic manager's office, where I receive a further instruction. File this instruction here, pick up the incoming message, take it to the waiting room, where you'll find there's one in the store already there. So, incoming message through one of the pickup points out here, and that says, mountain 4 miles ahead. Don't forget, we're in an aircraft. Off I go, the electronic clerk, switches clicking all the way along the data highway to the waiting room, which is down here, where I discover, right enough, we've got two messages. The one I've just brought, and the one in the store, which says airspeed 600 knots. The two messages are combined in the adding factory behind me. More switches click, the combined result is sent back to the store here, where we discover that the two messages put together tell us that the aircraft should turn 40 degrees right. The microprocessor has averted disaster.